Okay, so I'm going to do an overview of how we use our breadboards. So I have some equipment here. We have a battery. Okay, this is a switch. It's a push button switch, so you have to actually be holding the button down for the switch to be closed. These are resistors, LEDs, and these are wires that we're going to use to put inside of our breadboard. Okay, now the wires are different colors, but that's just showing their length. Otherwise, the color doesn't mean anything else. Now our breadboard looks like this. On either the right or left side, we have two lines. We have a blue one here, which is labeled negative. And anything you put inside of this blue line, let's say we're to put this wire here, for example, and then another wire here, it means those two wires are connected. It's no different from actually taking the two wires and connecting them like that. So this blue line connects anything that you put inside of it. Similarly, this red line connects anything that you put inside of it. And the same for the other side. However, if I were to put a wire here in this blue line and a wire here in that blue line, those two wires are not connected unless I were to actually bridge them like this. In that case, now this blue line and that blue line are connected. Now the blue and red lines are labeled negative or positive. And you don't have to put in a negative into the negative line, but it just helps to remember which is which. So what I'm going to do is I'm going to connect the battery. So if I put one wire into negative, okay, I am then just going to connect that to the negative terminal of the battery. And we're using 9 volts, so that's the large terminal. And then I'm going to do the same with the positive. I'm going to use the other side, and I'm going to connect that to the positive end of the battery. Like that. So now I have my power source attached, negative and positive. Now these here are resistors. We are going to use resistors because anytime we were to plug an LED, one of these small LEDs, into a 9-volt battery, that's too much energy, you're going to blow out the LED. So resistor is used to slow down the current. Now I'm going to create two circuits. The first circuit's going to be a series circuit, meaning one path only, and the next circuit's going to be a parallel circuit, meaning multiple paths that the current can take. So a series circuit, I'll connect one resistor with two LEDs in a series circuit, and then we'll follow the pathway. So let's start with the positive. So the positive comes out and goes in here. Currently it's connected to nothing, but I can connect it to a resistor by putting a resistor into any one of these holes on the red line. So I'll put it into here. Then I'll put it somewhere in the middle. So how does the middle of a breadboard work? Notice that all the rows are labeled from numbers 1 to 30, and the columns from A to E and F to J. Now for the middle ones, all the rows are connected. So row 1 from A to E are all connected to each other, and then separately, row 1 F to J are connected to each other. However, A to E is not connected with F to J. And that's the same for every other row. Each little row of 5 holes are connected to each other. So here I have the battery connected to the resistor, and I can connect that to an LED. Now for an LED, notice that the length of those leads are slightly different. The long lead is positive and the short one is negative. Now for an LED, because an LED is a diode, that's what the D stands for, we have to connect positive to positive and negative to negative, or else it will not allow current to flow through that circuit. So since this is our positive side, I will put the long side connected to this resistor here. And then I just pick any other random spot to connect it to. Then I can do the same with another LED. I'll start with positive first. I'll connect it to this one, and then I'll go complete the circuit by attaching it anywhere along this negative line back to the battery. So this is a series circuit. So if we follow it, you have electricity coming through here, and then it can only go into that resistor, then it can only go into this LED, and then it can only go into our next LED, and then back to the battery. So that's only one path. Alright, so now what we're going to do is we're going to make a parallel circuit. So in this case, in our series circuit, when we came in from the positive, we only had the choice to go into this resistor. But I can take another resistor and put it anywhere along that red line, such as there, and then again somewhere else in the middle. And now I've given the current a choice. As it comes in here, it can either go into this resistor or into this resistor. Okay, now in this case, it'll only go through this one because this one is not a closed circuit. But I can take two LEDs, just like I did up there, and create another closed circuit, connecting it back to the battery. And now I have a parallel circuit. One pathway is through here and back to the battery, and our other pathway is through this bottom circuit and back to the battery. So we have two choices. Right? So these are in parallel with these. Right? Now technically this would be a mixed circuit because these are in series with each other, just as these are in series with each other. But these three components are in parallel with these three components. And so this is a parallel circuit. So I want you to try and make this parallel circuit. Okay, I'm going to show you how to use these little button switches. And I'm going to attach it to this second circuit that I made here. So it actually bridges across this middle portion, like this. Now, if I were to attach across the top or across the bottom, the circuit is automatically closed and the switch really doesn't have much of a purpose. But if I were to put this resistor at the top, and notice the other LED is at the bottom, then it works as a switch. Okay. And I can also attach this light either in parallel to this light or in series with that light. Just do it in parallel here. And the switch goes on. Okay, but notice again these push button switches only close the circuit if you're holding the button down. Once you let go, that's it. Okay, I also want to show you just a reminder how to read these resistors. So, if we look at this chart, this is our color code chart for resistors. Now this resistor, if you can see, is red, red, brown, gold. Okay, so we have red, red, brown, gold. Red, red, red. It's a terrible red. That's all I got. Brown. I don't have gold, but I do have yellow. Gold. Okay. So, you look at the first red, And that's our first digit. And red is 2. So we write a 2. Okay, the second red is our second digit, which is again 2. So I write a 2. The third one is our multiplier, and brown is times 10. So I do times 10 ohms. So 22 times 10 is 220 ohms. Now the gold one is our tolerance, and gold means plus or minus 5%. So no resistor is perfect, okay, but this one means plus or minus 5%. So the resistance of that resistor can be 5% greater or 5% lower or within that range. Okay?